All right, so given an acute angle of a right triangle, identify the opposite and adjacent legs. All right, so in this case, they're saying use triangle QRS to find the following: the leg opposite Q. So this is my suggestion to you guys for all of this to find these different ratios. What I'm going to do is I'm going to circle Q, and the leg opposite that is where I can physically draw an arrow across it. So line opposite Q ends up being RS. Now the adjacent side is the side that makes up angle Q but is not the hypotenuse. Okay? So in that case, that's this guy right here, which will be QS. I'm going to write it right here with an arrow, not the hypotenuse. Okay? We're always looking at the legs, not the hypotenuse. I guess it would help if that looked like the word hypotenuse, huh? There we go. All right, the leg opposite angle R. So here's angle R. Opposite that is, again, where I can physically draw the arrow. That's going to be QS. The line adjacent is the one that is not the hypotenuse but still creates the angle. That's SR. And then the last thing we have is the hypotenuse, which is directly across from that right angle. That's always going to be, that is RQ. Okay? All of this, you always have to sit here and think, what angle am I using to find out what is the opposite and what is the adjacent? That is actually very important for this lesson, okay? So let's talk about parts of a right triangle, all right? And if we're looking at this angle right here, and we're looking at this side, this would be the adjacent leg. There we go, the adjacent leg. From here over here, this would be your opposite leg. This guy right here is your hypotenuse. And this will be your right angle. Is anybody still writing this down? Okay. Let's take a look at the ratio. All right, so it says the ratio of the lengths of two sides of a right triangle is called a trigonometric ratio. So I'm trying to clean this up a little bit for you guys. So the three basic trig ratios are sine, cosine, tangent. And their code names are just SIN, COS, TAN. Any questions on this so far? Anybody still writing? Okay, so we're going to use our scientific graphing calculator to evaluate each of the following to the nearest tenth. Make sure your calculator is in degree mode. So again, I want you guys to write this down just for you to reference later. To put in degree mode, you're going to hit mode, go to degree, enter. Okay. And then if you need to calculate the sine, cosine, or tangent, there's actually a button on there that says SIN, COS, or TAN. So does everybody see those three buttons? On your small calculator, they're there too. They're like right here. Should be like kind of right in the middle. Okay. Who does not see those buttons? All right. So what we're going to do first is we're going to round to the nearest tenth. So what I want you guys to do is this is very easy. You're already in degree mode, so that doesn't matter. I want you to hit, okay, the sign and then 53. What do we get? Round to the nearest tenth, it's what? 0.8. Cosine of 53 degrees ends up being what? 0.6. And then the tangent of 53 degrees ends up being 1.3. Who did not get these? Does the calculator make sense? Okay. All right, let's move on. So let's talk about SOHCAHTOA. This is a kind of mnemonic device for you guys to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if I want, so now you guys have like the angles part, right? So let me just get my color. So the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle is the opposite over the adjacent. Okay, now if we look here, we have O, we have H, that's where that comes from. We have A, we have H, that's where that comes from. And we have O, and we have A, that's where that comes from. Okay? So this is why it's very important to identify the angle. Always highlight or circle the angle so that this way you know what you're working with, okay? Pictures also help. Drawing pictures is going to help a lot with this. All right, so take a look. We're going to use this triangle right down here. They have triangle A, B, C. Okay? We're first going to work with angle A. So I'm circling that. I know my opposite is BC and my adjacent is AB. So when I find the sine of angle A, I'm using the opposite over the hypotenuse. The hypotenuse is right here. So this will be 8/17. Now for cosine, we're doing the adjacent over the hypotenuse. So the adjacent again is right here. Hypotenuse is 17. So we're going to have 15/17. And that's, remember, adjacent over hypotenuse. And then we're going to talk about the tangent of A. So the tangent of A is the opposite over the adjacent. So that means that's 8/15. Questions on that? I want you guys to try it for letter C on your own. So for letter C, remember, circle this, identify what's your opposite, what's your adjacent, and then what's your hypotenuse. Give these three a shot. Go ahead. All right, who's got the sign of C? Sign of C. Let's see. Samira, you're here today. What's the sign of C? What'd you get? 15/8. Okay. So we're going to do 15/8. All right, cosine of C, Rebecca. 8/17. And then the tangent of C, Yana. What'd you get? 15/8. You got 15/8 for the tangent? Oh, what's the problem here? 15/8. That's good for the tangent. What happened with sine? What's sine supposed to be? 15 over what? 15/17. Yep. That's okay. That's why we talk. All right, so those are the answers. Questions? All right, so how are the two acute angles of ABC related? All right, so in this case, they are complementary. What does complementary mean? Someone tell me, what does complementary mean? They add up to what? 90, very good. So they're going to add to 90. That is important information for these next few bits. So in this case, it says, what is the relationship between the sine and cosine of complementary angles? So if we look at this, let's just take a look at the sine of A and the cosine of C. What do you guys notice here? They're what? Sine of A is equal to 8 over 17. The cosine of C is equal to 8 over 17. So they're essentially what? They're the same, right? That's not a trick. So the important information here that you need to know is the sine of one angle is the cosine of the other angle. Okay, so the sine of one angle is the cosine of the other angle. That's actually very important because these have different degree measures. All right, letter D. Any questions on that? Is anybody still writing that down before I move on? Okay, letter D. If you know the sine of 68 degrees is approximately 0.93, what other trigonometric ratio do you know? All right, so here's what they're saying. They're telling me the sine of 68. That's what I'm going to focus on. Remember, the sine of one is the cosine of the other. So in order to find that cosine part, or the opposite one, we're going to take 90 and subtract it from 68. What's 90 minus 68? Jeez, this thing's just not cooperating with me today. What'd you get? 22. So that means I'm going to be working with the cosine of 22 degrees should approximately equal 0.93 as well. And what we're going to do is we're going to check our calculators with that, okay? So we're going to talk just type in the sine of 68. We're getting about the 0.93. Now type in the cosine of 22. What do we get? Same thing, right? But in order to find the other, you got to subtract it from 90 degrees since they're complementary, okay? So in this case, it says what trig ratio would be equivalent to the cosine of 17? I'm hoping on your paper it looks a lot better than what I have on the screen. All right, so now what we're looking at the sine of 90 minus 17. So this is going to be the sine of what? How many degrees? $90 minus 17 is what? 73. That's it. And if you punch both those in your calculator, you get the same. You should get the same answer. Okay. Questions on this first page before we move on to the other side? I would pay attention to the back because these are on your Delta Math today, so you're going to type in these answers. Okay. But before I move on, are there any questions? All right. Let's talk about this first example. So which segment is adjacent to T? All right, so here is T. I'm highlighting it. Which one would be the adjacent side? ET, LE, or LT? What do you guys think? Ooh, not all at once now. Too much. What'd you get? ET, yeah, this is the adjacent. This EL would be the opposite, so it should be ET. All right. Express the cosine of O as a fraction in simplest terms. So we've been dealing a lot with fractions, but we have not had to reduce them yet. You always reduce the fractions though, okay? Do not leave them just as big as possible. All right, so here's O. Oops. Here's O. I'm looking for the cosine, so that means I need my adjacent side and my hypotenuse side. So this ends up being the cosine of O is equal to 12 over 13. Can that reduce? Can it? No. So in this case, the answer is going to be 12 over 13. Questions on these two so far? All right, let's talk about the next one. So express the trig ratios as fractions in simplest terms. All right, so they want you to do all three of these, the sine of t, the cosine of s, and then they're saying the sine of t and cosine of s is what? Okay. So for the sine of t, first thing we're going to do is we're going to circle t. Let me grab a different color. Now remember, the sine is going to be opposite over the hypotenuse. So that's going to be 11 over 61. Does that reduce? Yes, no, maybe so. Check your calculators and hit math frac after. Does it reduce? Yes or no? Who says yep? Who says nope? Who wants to go home? Wow, you guys don't want to do anything. Okay, it's 11 over 61. Here we go. There it is. Cosine of s. Now remember, the sine of one is the cosine of the other. So what's the cosine of s? We don't even need to do anything with it. It should be the same. 11 over 61, right? Now for this next one. It said the sine of t and the cosine of s are what? Give me the words. They're what? Equal. So we're going to put are equal. And I'm going to give you a thing that says because RS is opposite angle T and adjacent to angle S. So there's that one and there's that one. Okay? So these three are in Delta Math. You're going to answer those and get some easy points. The rest, you're on your own for. Okay? Questions? Well, not on your own. You could always ask me questions. I shouldn't say that. All right? But it's your homework. All right. Get going. Those of you watching at home, have a great day.